Okay, hang on just a second. So I'm going to give everybody a chance to log into AP Classroom themselves. Because they're scrambled by class, I have to find them. Okay, here we go. So we're going to start with, I can't go by question number because everyone's test is different. So I'm going to go by question title, and then I'll share my screen with all of you as well. So the first question we're going to go over is called add one to everything, enhanced for loop. Add one to everything, enhanced for loop. Okay, so let me share my screen with all of you. Okay. So we're given a method called add one to everything that takes a parameter, that parameter being an array of integers. And the name of the array is called numbers. The return type is void. And in the body of the method, we can see a very straightforward standard for loop, which begins at the first element at position 0. So j is assigned to 0. As long as j is less than numbers.length. Okay, so numbers is the array, dot length, so the length of the array, and then j++. So we're going to loop through the entire array one by one, and we're not printing anything, we're not returning anything. We know we're not returning anything because the return type is void. And we often think that we have to print something when the return type is void, but that's not necessarily true. It can be something that just changes the value of something sort of behind the scenes. And that's the key to this question and the difference between a for loop and a for each loop, at least in the context of this question. So in the body of the for loop, we see numbers at position j plus plus. So notice the plus plus is outside of the brackets, not inside of the brackets. If it were inside of the brackets, at some point we would actually get a out of bounds exception error when the final element was retrieved or would be retrieved. When we would go to try and access the element after that, we would get an out of bounds exception error. So what's happening here is numbers at position j simply retrieves the element at that position, and we're going to add one to it, okay? And in fact, we are reassigning numbers at position j to, actually, I'm sorry, we're not reassigning numbers at position j to anything. We're just simply saying numbers at position j plus plus, okay? Yes, Matthew. So it says, which of the following code segments, if any, can be used to replace the body of the method so that numbers will contain the same values? Okay. Now, the common misconception here was that despite this for each loop appearing to be equivalent, the one subtle difference between a for loop and a for each loop that we haven't talked about as much as we have the other differences is that the variable num, which represents each element in the array, it refers to the element. It's not really the element itself. So we're taking this new variable and we are assigning this new variable to the value at each position. So by making a change to num is really like a copy of what is in each position. So by changing the value of num, the element, which is really just a copy, you're not actually changing any of the values in the array. So that's really what's being illustrated here. And this would be the common misconception of what people would think is equivalent to this. So this was the answer that was chosen the most, which was Roman numeral 1. You can see 13 people in this particular class chose that answer. I will address some of the other answers. So Roman numerals 1 and 3. Roman numeral 3 we could have eliminated very easily, because last week, if you recall, we went over this in a number of examples where we said numbers at position num, that's invalid syntax. Num, again, is a reference to the element in the array, all right? Num is not the index. There is no index variable in a for each loop. That's one of the drawbacks of a for each loop, is that you're not able to do anything with the index variable, okay? Whereas J here represents the index, and that represents the position of an element. That does not exist in a for each loop. So Roman numeral 3 we can get rid of because this represents invalid syntax, okay? Roman numeral 2, in a similar manner to Roman numeral 3, you would get some type of error message back because J does not exist. Okay, so anybody who picked the 7 people that picked, at least in this class, choice C, 2 and 3, 2 and 3 both had obvious errors. There was no such error in Roman numeral 1. It's just that you're changing the value of a copy. You're not actually changing the value of any of the elements in the array. So again, back to Roman numeral 2, J does not exist. J is an index variable that exists in this code segment, but of course has nowhere been declared or initialized in this code segment in Roman numeral 2. Okay, so there we're talking about a local variable here that's in this code segment and exists nowhere in this code segment in Roman numeral 2. And then again, with Roman numeral 3, numbers at position num is just invalid syntax. Num is a reference to the element. It's not an index variable. So 1 and 3 we can eliminate very easily. 2 and 3 we can eliminate very easily. And of course, D, we can eliminate that rather easily as well. So I can totally understand why people would have picked choice A, because it's seemingly equivalent to the code segment. But again, this variable num is a reference to the element at that position. It's not the actual element itself. So you're unable to make changes to the values of those elements, okay? In terms of like what's happening to the array behind the scenes. If you want to print out a value, like a new value where, let's say you had an array 1, 2, 3, 4, 5, and you wanted to print twice the value of each of those elements, you would have to say system.out_print, and then you could say num is assigned to num times 2. But that doesn't actually change what's in the original array. You're simply just printing out those values. You're not actually changing what's being stored inside of the array. So that's why the answer is choice E. None of the code segments will return an equivalent result. And it goes on to explain, the given method increases each element of the array numbers by 1. Code segment 1 does not work as intended. It assigns num a copy of each element of numbers. When num is incremented, it does not change the corresponding value stored in numbers. And then code segment 2 and 3, there's no need to read those. We've went over those extensively, okay? So are there any questions with regards to the add one to everything question? All right, I'm going to move on to the next question, which again, the numbers are going to be different for everybody. So I'll name the question. This question is called initial value of shortest. Initial value of shortest. Here we go. So 18 people got this question incorrect out of 31. Okay. So it says the code segment below is intended to print the length of the shortest string in the array word array. Assume the word array contains at least one element. All right. So our goal here is to assign shortest to the, well, rather, sorry. Our goal here is to assign shortest, or I should say reassign shortest, to the length of the word that is the shortest in the array, which contains a bunch of strings, and we're using this word variable to refer to those strings. So here's a scenario. What if we have an array of strings, and of all of the strings in the array, the shortest word has 10 characters, okay? So let's just assume we have an array. We can make it small. Let's say there's 3 elements where the first element has 10 characters, the second element has 12 characters, and the third element has 14 characters, okay? Now let's just assume we assign shortest at the beginning here to an arbitrarily large number, okay? And let's say that number happens to be 8, okay? So not that big, but let's just say you happen to assign it to 8. Well, the problem with that is that none of the elements in the array have a length that is shorter than 8. So what you would end up doing is returning shortest. So you'd be returning the number 8, which in fact does not refer to the length of any string in the array. So we don't just need an arbitrarily large integer here so that we don't encounter this problem in any scenario. We're going to, in order to rather combat this potential problem, we can assign shortest to the largest integer possible, not just some arbitrarily large integer. And we know that the largest integer possible is integer.max_value. So again, even though this is a multiple choice question, we can gather skills here or gather information that we could potentially use in an FRQ in a similar situation. It's certainly possible you could be given some type of scenario similar to this, and you might be thinking to yourself, what is a good value for an integer, or rather a variable that's going to refer to the shortest, of something here, and integer.max or integer.min could potentially come into play, okay? So by assigning shortest integer.max, we've now guaranteed ourselves that each and every element in the array will have a string that has a length that is shorter than integer.max value. Now you may be asking or thinking to yourself, well, I probably wouldn't have used integer.max value. What I could have done instead, which is actually very similar to another problem we're going to explore in a moment, is we could have assigned shortest to the element at position 0. So this is incomplete because it doesn't give us the method header, but we know that the code segment, as it says below, print the length of the shortest string in the array word array. So if we can assume that this method, whatever the method is, we don't know what the name of it is, but if we can assume that it takes in a parameter word array, we could assign shortest to word array at position 0, meaning the first element in the array, and then just go from there and use that as a reference, okay? But that was not a choice here. It was not a choice. Yes, Jaswinder, good. Yep, that would also work, as we just said, but it was not one of the choices. Very good, very good. Okay. Next up, I want to go over missing declaration and initialization. Missing declaration and initialization, unless there's another one that's, no, yeah, there we go. Okay, so about half of everybody in this class got it wrong. All right, here we go. So this is a very similar scenario. In this case, we have a method called longest word, takes a parameter of words, which are strings, and we are going to loop through the array starting at position 1, where k is less than words.length. Remember, words is the name of the array, and then k++. We're going to go one by one. Notice here it says, which of the following can replace missing declaration and initialization so the method will work as intended? Well, notice that we are, in our loop, we're starting at position 1, not position 0. So that should immediately trigger something in your brain that we're going to need the element at position 0 as our starting point, as a reference that the second element will be compared to. And then if the second element is longer than the first, then we will reassign what longest we'll store. Okay, so by saying string longest is assigned to words at position 0, we've now assigned longest to the element at position 0. And in doing so, if we could go through the problem now, so it's the first iteration through the loop, we'd have words at position 1, dot length, so the length of that word. If it's greater than the length of the word at position 0, which was the default, which is what we included right here in the missing declaration, if that is true, then we'll reassign longest. If it's not true, then we'll continue on looping until we've finished iterating through the data structure. And when we've done that, we will return longest. So it is certainly possible that the first element in the array is a string that represents the longest string in the data structure, but it's also possible that one of the other elements may contain more characters, in which case it'll get reassigned at that point through the loop. Okay? So this is a complementary question to the one we just did that really illustrates another way to answer. It's two different ways you can answer these problems. All right, let's now take a look at, I've got a reverse method. Reverse method. Okay, so another one that was about 50-50. Okay, so interesting, a lot of people picked D, so we'll talk about why that is and why choice E is correct. So if we have an array that contains 7, 2, 3, and -5, notice that the length of this array is 4. There are 4 elements. And the new array contains the elements just in the reverse order. So the same number of total elements, just appearing in reverse. So -5, 3, 2, 7 should be returned by the parameter R, should be returned, and the parameter R should be left unchanged. So that's what's going on here in this first line in the body of the method, is we've declared and initialized a new array that will have the same total length as the original array being the one that is referred to in the parameter here. Okay, so notice we've declared this new array called new R, which is assigned to new int, and the total number of elements here is going to be r.length. So however many elements there are in the parameter, that's how many elements we're going to have in the new array as well. So notice here that we're looping from the very first element all the way to the end and going one by one. Now again, our objective here is to reverse the order. So if we just said our new array at position k is assigned to R at position -k, well, there's a lot wrong with this here. Okay, there's a lot wrong. Negative k. So if we had 0 here, okay, so at position 0, we were going to assign it to position -1. Okay, so that would give us an out of bounds exception error. This would initially work if we were using a different language like Python, where -1 actually refers to the last element in the data structure, but that doesn't work for us in Java. And even if it did for that initial time, that first time through the loop, the second time through the loop, k would get incremented, and k would be then 0, and we'd be assigning the element at position 1 to the element at position 0. So that wouldn't work out. And then we'd be assigning the element at position 2 to the element at position 1. So this would actually cause it, assuming it would work for -1, it would just actually cause the array to have all of the elements be the same exact number. So it would be like 7. Well, actually, it would take the last one, put it here, and then it would copy them over the rest of the way. So that's no good. Next up, we have new array at position k is assigned to r at position k minus r.length. So it's always good to try to think about it in the context of the example they give, which has 4 elements. So r at position length is 4. There are 4 elements, and k would be 0. So 0 minus 4 gives us -4. That's no good also. We don't want to be dealing with negative index values, okay? C has potential, but again, this is going to yield a negative index value as well. 0 minus 4 gives us -4. Minus 1 gives us -5. So that's certainly no good. Now, let's take a look at the one that most people picked that was not correct. So r at position length minus k. Seemingly, very similar to choice E. What's the difference here? Well, the difference is that D, the first time through the loop, is going to cause an out of bounds error, an out of bounds exception error. The length is 4, okay? The first time through the loop, k is 0. 4 minus 0 is 4. There is no element at position 4. Remember, the last element in any data structure is always going to be 1 less than its length or its size, depending on what we're talking about. If we're talking about arrays, its length. If we're talking about array lists, its size. So that's why choice E is correct. R.length minus 1 minus k, or R.length minus k minus 1. So the -1 is absolutely critical there because it prevents us from getting that out of bounds error the first time through the loop. So you can imagine now r.length is 4 minus k, which is 0, minus 1, which is 3. So new array at position 0, k is 0, will be reassigned to whatever the last element is in the original array. The second time through the loop, k increases, so k is 1. So new array at position 1 will be assigned to, again, the length is still 4 from the original array. 4 minus 1 is 3. 3 minus 1 is 2. So now we're taking the element at position 2, which in the context of this problem happens to be the second to last element, and then so on and so forth. So D was almost correct. The problem there was that you're going to get that out of bounds exception error. Okay? Any comments, questions, thoughts thus far? All right, moving on to the next one then. So we did the reverse method. All right, let's talk about this equivalence. Okay, where's the equivalence? Uh-oh. I wrote down a title that's not entirely accurate. Did we do for loop? Oh, wait, here we go. I think this is it. Okay, there we go. So we have a for loop equivalent to an enhanced for loop or a for each loop. Okay. So we have this sum variable which is assigned to 0. We're told to consider the code segment below where R is a one-dimensional array of integers. Okay, so this ARR here is just an array of integers. N will represent or refer to a reference to the element, each element in the array. So we are going to change the sum, the value of sum each time through the loop using a reference to the element in the array. So sum is being added to twice whatever the value is. Remember your order of operations. So we're performing the multiplication before the addition. So we are doubling the value of the element and then adding that to the sum. And then when we're completely done looping through the array, we'll print the sum. So which of the following code segments will produce the same output as the code segment above? So we can take a look at each one of these. Okay, so choice A starts off the same. Instead of using the for each loop, they're using a for loop, starting with k at 0 and going all the way through r.length k++. So your for loop header here is perfectly fine from what I can see. However, I see. Okay, so in the body of the for loop where it says sum plus 2 times k, remember k is the index variable. We're trying to double the value of the element and then add it to the sum. So what this would have to say in order for choice A to be correct, it would have to say ARR at position k in the square brackets, and then choice A would be correct. But because it doesn't say that, it's incorrect. K is an index variable. It's not the actual element. It did nothing to retrieve the element from the array. So A is no good. Choice B, for the same reason, is also no good. But in addition to that, this less than or equal to would cause an out of bounds exception error. So you've got two things wrong with choice B. It's good to see that only one person chose that answer from this particular class. Then choice C has even more errors going on. Again, we know with a for each loop that there's no way you can loop through parts of the array using the for each loop. If you're going to use the for each loop, you know that you're going to start from the first element and go all the way to the last, and it's going to be done one by one and so on and so forth. So C has a multitude of errors. It's starting at position 1, so we've missed out on the element at position 0. We're going to get an out of bounds exception error here, and then also it's using k, which is the index variable. It does nothing to retrieve the element. Choice E, on the other hand, it initializes sum to the first element in the array. Okay, that's fine. And then it starts at position 1. So that's okay also because we've initialized sum to the element at position 0. And everything about choice E is good, with the exception of the k is less than or equal to r at position length. So if this had just said k is less than r at position length, then E would have been acceptable as well. So for those reasons, D is the correct answer. Sum is initialized to 0. We're starting at position 0. We're going through the whole array one by one, and we're retrieving the element r at position k. Okay, so that's choice D is the correct answer. All right, I believe I have one more here. Give me just a second to find it. What what this consider, perhaps it was this one. No. Oh, here we go. It looks like this class did okay with this one. All right. So one thing that needs to be what we need to remind ourselves of is that when we declare and initialize an array, it's different. It's a little bit different from an array list. So depending on the data type, the array will be filled with default values. Okay. So if you declare an array of size, 8, it's going to have 8 total elements, and the array is going to be an array of integers, then at each position we will have a 0 until that position gets reassigned. And if it's strings, then it'll be null. Okay, if it was doubles, it'd be 0.0. So we have a new array of integers, which is being assigned to the length of the array that's given to us as a parameter. Now, the only two things that are changed in this array are this new array at first and new array at second. So notice it says that which of the following will result in array 2 having the contents 0, 0, 13, 0, 9, 0, 0. So the only elements that change are the first and the second. Well, we can determine what first and second are by looking at the array here. So this is position 0, 1, 2. So first is going to be 2, 3, 4. So second is going to be 4. So we know that we can eliminate choice C because it uses 3 and 5. So sorry for the 4 people that chose that in this class, but C is no good, and we figured that out by determining which elements had new values. Okay. Now, choice A and choice C have the same elements in their array: 5, 2, 8, 6, 4, 3, 9. D is slightly different. B is very different. E is very different as well. So what we need to figure out is what's going to make, right? We need to focus on what's going to be at position. What is going to be at position 2, and what's going to be at position 4. And by adding what value to those, we'll make those numbers 13 and 9. So here we go. Well, rather, we now know that num is going to be 5 because it is for choices A, B, D, and E, which are the only choices left. And it was for C as well, which we happen to be able to eliminate. So in fact, since we know that num is being added to array at position first and num is being added to array at position second, we can just do the inverse operation. So take 5 away from 13, which gives us 8, and take 5 away from 9, which gives us 4. So the element at position 2 should be 8, and the element at position 4 should be 4. And that is represented in choice A. Okay, and we could go the other way. 8 plus 5 is 13. 4 plus 5 is 9. And all the elements are zeros because, again, because of this line here, when the array is declared and initialized to have a length that is the same as the array given to us in the parameter, it creates an array with 1, 2, 3, 4, 5, 6, 7 total elements, all zeros. And until we reassign them to new values, they remain 0, which is why only the element at position 2 and the element at position 4 are given new values. Okay? All right. All right. Was there anything else that you wanted to take a look at? Do sum and the shuffle. Okay. All right, let's take out do sum. What's the name of the question? Oh, do sum or do one method? Oh, I got it. I got it. Okay, 1 second. Okay. All right, so we have some method called do sum precondition. R contains only positive values. The return type is void. It's a class method. It takes in an array of integers, and we have some other parameter here called lim. So we have this variable v, which is assigned to 0, k, which is also assigned to 0. So we have the while loop. Okay. As long as k is less than the length of the array and the element at position k is less than lim, okay, so that makes sense, less than the limit, then we're going to continue looping. So if the element at position k is greater than v, then v will be reassigned to r at position k and then k++. So it says, assume that do sum is called and executes without error. Which of the following are possible combinations for the value of lim? Oh, second. Okay, so it says, assume that do sum is called and execute without error. Which of the following are possible combinations for the value of lim? The number of times statement S is executed and the number of times statement T is executed. So value of lim, they give a couple of different options, 5, 7, and 3. Execution of statement S, execution of statement T. So they tell us how many times that particular line of code will be executed. So given those combinations. So if choice B is the correct answer, Roman numeral 2, that would mean that Roman numeral 1, so given the value of a lim of 5, that either the execution of S, which is here, sorry, it's not letting me highlight it, but the execution of statement S is 0, and the execution of statement T would be 5. So one of those numbers or both is inaccurate. And then the same thing goes for Roman numeral 3. So given a limit of 3, the execution of S would be 5 and the execution of T would be 2. One of those numbers or both is incorrect. So let's just start with Roman numeral 1. So given a limit of 5. So here's what I would do. I would create just an arbitrary array of positive integers, keep it small. So I'm going to go with 1, 2, 3, 4. So 4 elements at positions 0, 1, 2, and 3. So while k, so that would be 0, is less than the length of the array, so that's true. And the element at position k, so that's r at position 0, so that gets us that gets us 1, okay? And that's less than the limit. So the limit being 5, so that's true. So if R at position K, so that's the element at position 0, which is 1, is greater than V, well, that's false because we said that the element is 1. And we know that 1 would be the smallest possible value because it says R contains only positive values. Okay? So R at position K is, oh, I'm sorry, greater than V. That's a true statement. I'm sorry. So that statement will always or should always be true, okay, because we cannot have a negative value in the array. So V, which is 0, initially, is going to get reassigned to the element at position K. So V will be reassigned to 1. So now we have V is assigned to 1. And we increment K. So K also becomes 1. And we continue to loop through. So in this particular case, we said the limit is 5. So we're going to execute. We're going to continue executing because all of the elements in the array are less than lim, which is 5. So the fact that executions of statement S, if executions of statement S is 0, that would simply mean that that the elements in the array are greater than 5, okay? Or at least rather the first element in the array is greater than 5, because if that is true, then we never enter the body of the loop here, and we simply just, we're done. The loop never gets started, okay? But with that said, it's not possible for us to be able to execute statement S 0 times and also execute statement T 5 times. So we'd have to think of a scenario in which case we'd enter the body of the loop, but the conditional would be false every single time, and thus we would just continue to iterate K. So my guess is that that's not possible, right? So let's all try to think of an example in which case this would be false every single time, but that we would be able to enter the loop, okay? So the scenario then would be if, let's say we had elements 3, 4, and 6, where the limit was 5. So we would go through twice, okay, V being 0 the first time through. So as long as this is true just one time, as long as the while loop here is true one time, the if statement will execute at least once, okay, until V is reassigned. So there's no possible way that V will not get reassigned to a new value, given that this is true. So if this part of the while loop is true, then this part of the condition here will absolutely be true, okay? Because the array has to contain positive values. And even if it didn't, the limit is 5. So that negative value would be great. Oh, I'm sorry. It's irrelevant because the array contains positive values. So, and since V is set to 0, which would be, it's sort of like the stop limit, we can't have an integer smaller than 1. You're always going to execute statement S at least once. So that's how we can eliminate Roman numeral 1. Let's go ahead and eliminate Roman numeral 3. So given a limit of 3, so that means that we're only going to continue to iterate through the data structure if the elements are 1 and 2. So if you have an element that at any point has the number 4, 4 or greater than 4, greater than or equal to 4, we're going to stop. So it's not possible, right, for us to execute S 5 times and only execute t 2 times. Notice the k++ is outside of the condition. So let's say this is true every single time we go through this condition here. Well, k++ is going to happen regardless of whether or not this condition is true or false, which means that the largest discrepancy, or I should say the smallest discrepancy between the two could be 0. So you're never going to have a negative discrepancy, which is what this would be. So t minus s, the smallest number you could possibly get would be 0. Again, because k++ is going to happen regardless of whether or not this is true. So there's no possible way that this could occur 5 times, that this could be true 5 times, and that k++ wouldn't also be 5. So if s was 5 and t was 5, then maybe that is possible. Okay? So that's why 1 and 3 are incorrect. If s here was 1, then that could be possible. If t here was 5, then this could be possible. So t has to be greater than or equal to s. That's the key to this question. Not so much the limit. The key here is that t has to be greater than or equal to s, and choice Roman numeral 2 is the only one that illustrates that. Okay? Shuffle method. Okay, give me a second. I just got logged out. Give me a minute. All right, it's happened again. Shuffle, shuffle, shuffle. All right, so I suppose we go through this whole question together, because I'm sure we're at different sort of levels of understanding in the question. I'm sure some people were just totally confused by it. Others may have gotten close. Some of you, of course, got it correct, but perhaps you got it correct and don't really know why. All right, so they give us 2 examples here of these arrays. One represents sort of the original array, if you will, which is the parameter, the input to the function. And of course, we can see the return type of this function is int array. So it returns an array of integers. And we see in the first line of code within the method, n is assigned to nums.length. And throughout the body of this loop here, we are assigning result to values that have some type of relationship with nums. So the resulting array will be of the same length as the original array that was given to us as an input. Okay, that much we know and we can see. Now, the 2 different examples here are meant to show you what happens in one scenario when we have an even number of elements. So we see that the index of the final element is 7. Of course, we know that the first element has an index of 0, so there are 8 total elements here. And we can see that in the original, we have 10, 20, 30, 40, 50, 60, 70, 80. And what happens, it looks like, is that the elements it positions 1, 2, and 3 are shifted into positions in sort of like an every other manner. So 1 goes to 2, 2 goes to 4, 3 goes to 6. And notice 0 stays the same. So 0 stays at 0, 1 goes to 2. So 2 is twice as much as 1. 2 goes to 4, 4 is twice as much as 2, and 3 goes to 6, 6 is twice as much as 3. And we can see that here, result at position J times 2 is being reassigned to nums at position J. So that's where we're getting the 10, 20, 30, 40 at a position in the resulting array where it is being filled into a position, relatively speaking, twice as much in reference to the original index, okay? So that's this line of code here. The second line of code says result at position J times 2 plus 1, and in this case, so this is going to be, so when J is 0, that'll be position 1. So position 1 is going to get reassigned to J plus N divided by 2. Remember your order of operations. So N, which is the length, that's 8 divided by 2, which is 4. 4 plus J, with J being 0, would be 4. So the element at position 1 will be assigned to the element at position 4. So whereas 50 in the original, it's at position 4. And then we continue to go through. So J is 1. 1 times 2 is 2. 2 plus 1 is 3. So the element at position 3 will be, again, the length is 8. 8 divided by 2 is 4. 4 plus 1 is 5. So we get the element at position 5, 60, and we continue on from there. So which of the following best describes the problem with the given implementation of the shuffle method? Now, in example 2, we're given another scenario where instead of having an even number of elements, we have an odd number of elements. We have 7 elements instead of 8. And notice that there's a piece of information that is lost. So we have 10, 20, 30, 40, 50, 60, 70, and the result is 10, 40, 20, 50, 30, 60, but we don't have the 40, okay? Now, I'm going to assume, and I'm just going to reread this again, that that's the way that it should be, and that where it says the following implementation of shuffle method does not work as intended. So our desired result is in fact what we see in example 2, but this set of code does not operate that the way that it should, okay? And my first thought is that these two are in the reverse order. So if we continue to go through, and somebody's made a comment, what do you mean? Hold on, Wilson. What did I? 10. Oh, I'm sorry. 40. We don't have the. So we have 10, 20, 30. 10, 20, 30, 40, 50, 60, 70. And we have 10. Oh, I see. So it went 10, 20, 30, and then 40, 50, 60, 70. I see. Okay, so we didn't lose the 40. Okay. So I'm sorry. No information was lost. I misspoke. I was thinking in terms of the first example. So let's take a look at why. Let's take a look at why the last element of the returned array may not have the correct value. So we've just gone through, well, let's just go through it with this now. Okay, so the element at position 0, 0 times 2 is 0. Nums is position 0, so this stays the same. Then we have 0 times 2, which is 0, plus 1 is 1, and that's going to be reassigned to, well, the length of the array is 7. 7 divided by 2 is 3.5, but we're doing integer division, so it's 3. 3 plus 0 is 3, so nums at position 3 is 40, so the 40 gets placed at position 1. So far, so good, okay? We're going to continue to iterate j++. So now we have j is 1. 1 times 2 is 2. So the element at position 2 is going to be assigned to nums at position j, which is 1. So the element at position 2 is going to be assigned to whatever was at position 1 in the original array. So far, so good. That worked out just as we hoped. Next up, we have j times 2. So 1 times 2 is 2. 2 plus 1 is 3. So now we're going to be assigning this element here a new value. And again, the length is 7. 7 divided by 2 is 3.5, but we're doing integer division, so that becomes 3. 3 plus 1 is 4. Okay? So the element at position 4 is 50, and we're assigning that into the element at position 3. And we put the 50 right there, so everything up until this point is perfect. Next up, j++ again. So j is now 2. Okay. So 2 times 2 is 4. So the element in position 4 is going to be getting a new value. J again is 2. So nums at position 2 is 30. So the element at position 4 is going to be assigned to 30 right here. Then we have 2 times 2 is 4. 4 plus 1 is 5. So the element at position 5 is going to be reassigned to, again, 7 divided by 2 is 3.5. Integer division gives us 3. 3 plus 2 is 5. Okay? So we're reassigning the element at position 5 to the element at position 5, 60 and 60. So that works perfectly fine. So now, j++ again. J is 3. Okay. Here's a potential issue. J is 3. 3 is not less than 3. 7 divided by 2 gives us 3.5. And thus, we never got a chance to reassign. We never got a chance to put the 70 here. You might be thinking, well, wait a second. The 70's here, so doesn't it just automatically copy over? That's not true. We know that from this line of code right here, int array result is assigned to new int at position n. We said a couple minutes ago that when you declare an array with a specific size, depending on its data type, it will get filled in with a bunch of zeros if it's ints, null if it's string, 0.0 if it's doubles. So we know that this array result is going to have all zeros in it to start. So after executing this set of code, given the fact that we have this nums, this last element here is going to store the number 0, not 70. Okay? It's going to store the number 0 and not 70. So that is a problem. A way that we might be able to fix this is if let's see, we would have to change the condition here to less than or equal to. Okay, we'd have to change it to less than or equal to. And would we then get a out of bounds at any point? No, we wouldn't. So if we changed it to less than or equal to, then we would be able to go through where j is 3. So 3 times 2 is 6. Nums at position 3. Nums at position 3. So that wouldn't work. That wouldn't work either. So I'm not sure. That would be something interesting to think about, how we'd be able to fix it. But it definitely doesn't work. And we just established that it's, given this scenario, the last element could potentially be left out, which is what choice C represents. The last element of the returned array, result at position result.length -1, may not have the correct value. So it would have the correct value, I think, with an even number, but with an odd number, you're going to run into that problem there. And in this example, we just illustrated that the final element at position 6 would be 0 and not 70. As when it's odd, both sides are not equal and creates a problem. Yeah. It only works when it's even. Yep. Exactly. What do you mean remove leftover numbers, Matthew? Like, was it meant to remove the 70? Um, no, I don't think that was the I mean, we don't, it's just a hypothetical sort of method here and scenario. So I can't really say what the intention, well, no, I mean, we do know what the intention was that it, it created a new array with the elements sort of shuffled up. I can't, I mean, this here, what's in the for loop would represent the algorithm that is shuffling them. Okay. Um, just the issue is that it doesn't shuffle them, right? Because there is information that is lost, right? So the 70 doesn't actually get put in here. It just stays as 0. So you would have to think about, and I'll think about it myself as well, how we would be able to fix this. So, excuse me, so that the 70 does in fact get copied over and that there's no data lost in the array. Okay? So it's not this implementation, it's not good enough. It's not good enough because it doesn't do what it's supposed to, which is just shuffle all the numbers around, right? So almost think about it like we have a perfect example. All of you just took this assessment, right? There happened to be 16 questions, but what if there were an odd number of questions, right? So I clicked an option that shuffled all the questions up. So by me clicking that selection, there was some type of algorithm very similar to this one, where you can think of the exam as an array of questions. Okay, and there were an even number, but if there were an odd number, there could have been some type of data lost if the shuffling algorithm wasn't correct. If this shuffling algorithm was used in AP Classroom and I had selected an odd number of questions, it's very possible that someone's final question would have gotten left out and it would have just been blank. Is the algorithm supposed to, then how it assign the last index to 70? Jesswinder, you're gonna have to ask me that question again. Type that out again. I'm not quite sure what you mean. Correct. The last element in the result array never got assigned to 70. And remember, we said when you declare and you create an array of size whatever, it gets filled with default values. So the array contained all zeros. The length of the array, we were told in that first line of code there, is supposed to be the same as the array that was given to us as a parameter. So it's filled with zeros, okay? So each and every element is 0 until we reassign it. The last element was never assigned. What they're saying here is, here are examples. It says consider, right, as illustrated in the following examples. This is what we want to happen. We're not saying this is what happens given the code segment. They're saying this is what we want to happen. Now here's a method, or here's an implementation for the shuffle method that does not work as intended. Why doesn't it work? Okay. So again, they're not saying that examples 1 and 2 illustrate the shuffle method that's given. They're saying this is what we want to happen, and it's not happening given the set of code that we have. Okay. And then it's saying under what circumstances will it not work? Well, we demonstrated it will not work in some cases given the final element in the array. So the final element in the array, when we have an odd number of elements, will not get reassigned to the correct value. It will be left as 0. Okay, great. So one thing that I just want to let everybody know, after we're done with our conference in a moment, I'm going to assign the horse barn problem. Hopefully that sounds familiar. It's actually from the 2012 exam number 3. It has to do with arrays. So that's going to be our next problem, and we'll go over that problem on Thursday. We already did it, but that doesn't mean that I can't imagine that everybody has the solutions to those problems A and B already memorized. So I've done many of these problems multiple times, and you learn something new every time, because it's not like, I don't know, it's not like maybe a social studies multiple choice question where you just memorize a fact. It's a little different than that. So we're going to do the horse barn problem again, which hopefully will act as a good warm-up, because we have done it, much earlier in the school year. And we're now going to be focusing our attention on problems very much like the horse barn problem from 2012, number 3. Our exam, our AP exam is, let's see, is in about 3 weeks. It's a little less than 3 weeks. So it's 2 weeks from this Friday. This Friday is May 1st, and our exam is on May 15th at 4 p.m. So we have, let's see, we have 14, 15, 16, 17, 18. We have like 18 days left. So I would say for the next, maybe 10 days, we're going to exclusively be working on FRQs with arrays and array lists. And then for the last couple of days, we'll go back and just mix them all up between the two. So keep pushing. We're in a good spot, and I always try to find the sort of the positive, whatever positive I can take out of a situation. In this particular situation, we know there are going to be 2 questions on the exam, and we know exactly the topics that they're going to cover. We know that one question is going to be very much like 2012 and 2013 number 1. Or 2018-19 number 1. And we're also going to have a question that's very similar to this horse barn problem. Okay? So those are the 2 types of questions we're going to have. All right? So in the meantime, go back and study those problems we did in the last week or 2. The climbing info class and the music one, and the frog simulation. You should know those 3 problems by heart, okay? You should know those in and out. If you can go back and read those questions, you look at your solution, you're going to make connections between these things, and come the day of the exam, you're going to get something similar to it. And of course, you're going to have to write, a brand new set of code, but the similarities between these questions are striking. And if you're very familiar with, a particular question type, you can certainly draw on your experiences, your previous experiences in developing a new set of code. So please go back and study the methods that the FRQs that we've already done. Okay. So I'm going to post that up. Have a great day, and I'll see everybody on Thursday. See everybody.